I am the Tofu Golem. Please enjoy the video.
You start by defining a camera object with position, rotation, field of view, and clipping planes so rendering has a clear reference. Once done, attach that camera to the scene root or bind it to a specific entity so transforms propagate. Make sure to initialize FOV to 60 and aspect ratio to viewport width divided by height. This prevents distortion. If your framework needs a projection matrix, compute it now from FOV, aspect, near and far planes, so the renderer can accept frames immediately. You now implement transform updates and input controls so the camera moves correctly. First, compute view and world matrices each frame, then apply parent transforms if the camera is childed. Next, add control modes, follow for targets, orbit for pivots, and first person for free movement, so you can switch behaviors. Use linear interpolation or spherical interpolation for smooth transitions and clamp pitch to avoid gimbal flip. Once you wire input to velocities and damping, the camera will feel responsive and stable during scene navigation. You finish by ensuring projection updates and performance safeguards are in place. Recompute the projection matrix on viewport resize and update the aspect ratio so the scene remains correct. Then extract frustum planes from the combined view projection matrix to cull off-screen objects, improving frame rate. Finally, add debug gizmos for camera axes and a fallback default camera so rendering can continue if your camera throws an error. If the view is black, check near/far values and matrix order first as the primary troubleshooting tip.
Thanks for watching. Consider subscribing if we helped you today.